Hello everyone. In this video, we are going to solve the problem shortest path in 1-2 graph. So basically, this is the POTD problem of GFG. So let's get started. So in the question, we have given a weighted undirected graph with b vertices numbered from 0 to b minus 1 represent by an array edges where edges of I contains u of I, v of I and w of I, which indicates that there is an edge between U to V with a width W. Okay, so and two vertices we have given source and destination. Find the shortest distance from the source to destination. Okay, the shortest distance is defined as the minimum total weight required to reach destination starting from the source. So we have to return the shortest distance from source to destination. If it doesn't reachable, then we have to return -1. Okay. So basically, this is a very famous problem. This is called also known as the Dijkstra's algorithm problem. Okay, so you can search Dijkstra's algorithm as well, and the today's solution is also depend on Dijkstra's algorithm. So let's take the first test case we have given these edges, and we have to find the shortest path from source to destination 3. We have source as 0 and destination is 3. So we have to find the shortest path. Which path is going to be the shortest path? Okay. So by looking, we can easily say the shortest path is 3 because 0 to 2 is 2 and 1 3. And again, we can say this path can be considered or this path as well 0 1 2 and 3. This is also considerable. So path from 0 to 3 is 3. Okay. In the same way, we have this one v equals to 5 and ages equals to we have given. Then we have given the source equals to 1 and destination equals to 3. Here you see we have given source 1, but destination is in the another graph, which means this is the one and this is another one. This is the graph 1, graph 2. So these are disconnected graph. This is a disconnected graph. So here from source to destination, this is the source and this is the destination. There is no way. So that's why we have written -1. Okay. So these are some other test cases we have. And if constraints, we have constraint number of vertices be lesser than 10 to the power of 5 and edges size we have given. And okay, this is. So we have to return the shortest path. So for this, we are going to use the Dijkstra's algorithm. We know that Dijkstra's algorithm is a greedy algorithm. Greedy means it takes the local minimum. Okay, so it will find the shortest path between two. Okay, then update it. So it's a greedy problem. I mean greedy approach. So let's see how do you want to solve this. So you are given the function shortest path. So let me maximize this. Okay. So we have given the function shortest path in which we have given the vertices, number of vertices, and the source and destination and the edges. So what exactly we are doing over there? First of all, so here we have made the adjacency list. But why? So the reason is that if it doesn't make the adjacency list, first of all, it's hard to get the values from the edges. Another one is that the time complexity would be more. Okay, in this, if we use the adjacency list, then we will have the complexity of v plus e, where v is the number of vertices, e is the number of edges. Okay, if we doesn't use, then it may go to the v cross e. Okay, so that's why we have made the adjacency list. So how it's made? So it's simple. Just make a array list of list in which we will store pair. So we have defined here pair class in which we have two class variable v and w, and we have a constructor v and w. This dot b equals to b, this dot w equals to w. So there's a simple class. Okay. So we will store these pair into the list. And first we create the list, and then again we will make 2D list. Okay. In that 2D list, we will access each edge from this edges and take U, V, and W. And then just simple, we will take the youth list and store the pair, and VH list and store the pair. Okay, simple. So in this way, we will make the adjacency list. Now from there, our logic starts. Okay, this is the distance array. Integer distance equals to new integer b. This is the distance array of size b, and we have initialize this by infinity value. Okay, starting from the infinity. Then we make a priority queue for Dijkstra's algorithm, which is a min heap in which we have pq equals to new priority key, and we have passed an comparator. Why so? Because we have pairs. Okay, so how we will get to know that which weight should be come first? So that's why we have passed a comparator in which this will compare based on the dates. Okay, now we have set the source weight as 0, distance of source, because source to source it would be 0, and then we will just offer it to our priority key. Okay, yeah. Now this is our Dijkstra's algorithm logic. Okay, understood this. What exactly is this? While PQ is not empty, till then we will pull the elements from the priority queue. Okay, so we have named it as current. Then we make a variable u and extract the value from the pair currents. Okay, so we have v and the weight. Now this conditions, if current distance is greater than distance of u, then we just need to continue, because here we already know that we have the distance of u already less than the current distance. Okay, so then we no need to go further, we just continue from there. For example, if I tell you here, if current distance is greater than distance of u, so let's suppose initially we have a store something like 1 comma 3. Okay, and then we will get like 2 1 comma 3 we have stored, and it have some larger weight, but the distance of u we have less, then we just no need to change, we just continue. Okay, now this is the quickly exist, but we can remove this as well if it's not necessary. If we got the u equals to destination, then just return the distance of u. Okay, because it's a greedy algorithm and it will get the answer within the traverses. Okay, if u equals to distance, we can just return. Now this is the logic of our edge relaxations. Okay, this one. Now we have made a loop on the neighbors of u, and we will check the distance of u is infinity. If it is not, then we will check this condition. Distance of u plus weight is less than distance of v. If this condition is follows, then we just need to update this, and we will offer it to our priority queue. Now understood this. Why this condition? This condition is called edge relaxation, and how it's work, let's understood here. So I have created a simple graph. This is the 0, 1, 2. We have 3 nodes, and we have distance 4, 2, and 3. Okay, these are the bits. So I have made a distance array initialized by infinity, and set source to source bit is 0. Now in the age relaxations, what we have, distance of that node distance of u plus weight is lesser than the distance of v. Okay, which means that distance of source plus weight is less than distance of destination. Then we will just update the destination. So how we will do this? Let's see here. We want to go from 0 to 1. So in that case, distance of u means 0 to 0 we have 0 plus what is the weight from 0 to 1? It's 4. So 4 is lesser than distance of v. Distance of v means distance of 1, which is infinity. Okay. So this condition is true. 4 is less than infinity. So what does that mean? We can update the distance of v equals to 0 plus 4. Okay. So we can just distance of v equals to 4. Okay. So this is the logic of edge relaxation. Now see. So we have distance of u is not equal to integer dot max value. If distance of u plus weight is less than distance of v, then we just update our distance of v and offer it to our pair. Okay. And after completion of our Dijkstra's algorithm, we just return what if the distance of the destination is integer dot max value, which means if we got this case the source is 1 and destination is 3, then there is no way to reach to the 3, so that's why it will be infinity. Okay, if this condition is followed, distance of destination equals to integer max value, then just return -1, otherwise return the distance of the destination from the source. So that's is the problem, and in this way we will solve. Hope you like this video. If you have any doubts, so you can ask me in the comment section. If you are new to our channel, so make sure you subscribe our channel and like this video. Thank you. Thanks for watching. See you soon in the next video.